Okay. Look, so we got great attendance today. I see 39 folks have joined, and no doubt it's because of the awesome invited experts that we have here to talk about Nerf. And I think, Guido. I think Guido mentioned this to me at SIGGRAPH last year and said, "Hey, the Adobe research folks and tech transfer are doing some great work with Nerf, which was very popular last year in terms of alternative geometric representations with some interesting characteristics." And that they're looking at ways that it may fit into an open standard. So just so happy here to have Jay and Raymond here to brief this. So Jay and Ray, over to you guys.
Hi, hello, I'm Raymond, and may I share my screen?
Yep, yeah, I just stopped
Okay,
sharing. So
yeah. So I'll just brief our practice about the neural assets we do in Adobe. Here's an overview of how we do this. So we have two formats. One is Adobe NGP. It's actually a variant of instant NGP paper, the great paper from NVIDIA. And uh, we use that as one kind of representation of the 3D object, and another is Gaussian splats. So we store NGP into our custom glTF format, and for gsplat, we just follow the tradition, or currently what the others are doing, using the PLY format for gsplat. And because we also want to make them integrable with meshes, lights, cameras, extra, we convert both of this format into USD. So we have USD schema for both the Adobe NGP and the gsplat. We're still working on the USD schema of gsplat. And we do have make them interchangeable. For example, you can convert a glTF NERF or glTF NGP asset into a USD asset, or convert from the USD asset back to glTF. And also the same for USD PLY to USD, and vice versa if the USD only contains the gsplat itself. So because the PLY is harder to be composited, so we only convert the gsplat from, or like extract the gsplat from the USD. So that's our like strategy for applying the neural sets here. And I can go to more detail about Adobe NGP. So here is the data flow in Adobe NGP. So for a camera array, we just use a 8-bit distance grid to do remarching and sampling to find the position closest to the surface, and then use another 8-bit density grid to sample positions for adaptive sampling. So here is something that could be a bit different than the other implementation, where we are not just using a diffuse MLP, but we are using an additional 8-bit density grid to assist adaptive sampling, which has accelerated the rendering process a lot. And then we query a hash table like instant NGP, and go through a diffuse MLP for diffuse color, and we combine the transformed feature plus the view direction, the process the view direction vector, and go through a view-dependent MLP, and got the final color containing the diffuse and the specular colors. So here are some tech specs. We have a 1 to 8 cube distance grid stored in unsigned integer 8-bit, and a density grid of 512 by 512 by 512, And a hash grid, we use 8 levels of hash grid. Each level contains a constant buffer, a constant length of buffer, and each buffer is 4 elements of float 16. For the MLPs, because they are small, we just store them as 32-bit float to get the precision. It could be compressed more, I think. So for diffuse MLP, we use a 2-layer small MLP, and for the view-dependent one, we use a 3-layer ones. And we pack the MLP weights into 4x4 matrices for vectorized multiplication during the rendering. And the corresponding glTF schema is like this, where we have a node, have an extension of node called Adobe Nerf Asset. And for each of the field, like the hash grid, we encode them into a base 64 format so that we can read back them easily if we render it on the web. Yeah. And the corresponding USD schema is pretty straightforward, where we just have the corresponding fields for the hash grid, distance grid, and density grid. And a difference here is that we don't compress them or quantize them, because in USD's support, the unsigned integer support is not as good as the float. So especially when you want to compress them. So we use the USDC format to let the USD itself to compress these fields instead of we present some custom compression algorithm for it. Here is the PLY for Gsplat, which is pretty standard or normal. We have the central position and normal and diffuse spherical harmonics, specular ones, and the scaling quaternion. And this is the PLY used by, I would say, a lot of people in this industry. And so that we have developed the first very initial version of USD schema, which is basically a translation of the PLY format, where we built this custom schema on USD GM points, and we just add those missing field or additional attributes into this schema, like the diffuse color, the specular spherical harmonics, the scaling, the rotation. So it's basically a point cloud plus a bunch of attributes. And I'm pretty happy that we are invited to this forum, because we really want to make this schemas more extendable. And we're happy to know, like, for example, how many companies are adopting NERF or NGP, and or how do they use NERF in their applications. We also want a more extendable Gsplat schema, because the current one is just a direct translation from the PLY. So, for example, maybe in the future we could support variable orders of spherical harmonics. Currently is fixed to be order 3, and maybe in the future, like our researchers has proposed something like using spherical harmonics to encode more detailed opacity or density, instead of just using a constant for each point. Is that possible to be done in a schema, or like some unified format for both Gsplat and GP? Or we also glad to hear what are the practice in other companies for the Gsplat format, in particular regarding to its USD schema. So thank you.
Awesome. Yeah, really appreciate you sharing all this, and it's it's cool to see the pen to paper here and how much work you guys have done. let's open it up for questions. Who has the first question? Well, if I could go first, I wanted to ask any of the schemas that you've shown, or is any of that like on GitHub at this point, or is that still just internal?
I think for the Adobe NGP, we have recently made it public along with the glTF USD conversion stuff called USD file format something, yeah. For the Gsplat, we're still working on the very initial version for this. Yeah.
Yeah, if I can add, I don't think, we haven't started the conversation yet about standardization either with Kronos or AOUST. So right now, yes, we will have it in the plugins to convert between glTF and USD, but I think a further conversation needs to happen. It's kind of a little bit of a chicken and egg. I asked many times in the team, like, are we ready to have that conversation? Is this thing still fast evolving? And and again, as soon as things are stabilizing on Nerf, okay, Gsplats are start to show up. And so that there may be potentially the need of like a dedicated conversation with some of the players that are producing these assets and some of the standardization about it to just see, are we ready to have that conversation? It's because obviously lots of interest in the e-commerce space for this representation because of capturing and delivering on the web. And obviously, to make it actually useful beyond showing videos and Twitter posts and all of that, needs to be standardized for real, for customers, for clients to say, yes, I'm going to convert a bunch of assets this way. So, and this is one of those forums where, again, we just want to hear where people are and if it's about time or there's still enough research that maybe we need a little bit of extra time.
By the way, are you guys thinking about open sourcing enough code so that USD View could actually render these things?
We're having that. It's interesting enough that the way kind of the team is operating, Ray and is operating right now is actually with an internal repo, especially designed with the idea that maybe at some point may make sense to open some of those aspects, like the shader that is used to visualizing it and the schema. So yeah, we haven't got to that point, but there may be a point that we were trying to debate, what is the timing? When is the timing to do this right? And what are the pros and the cons? But happy to have follow-up conversation if we believe that it would be, again, beneficial to each companies to actually try to centralize this versus each company have their own and not looking the same or not be able to transfer it across and stuff like that.
Yeah, we've I mean, we had conversations with Spiff about ideas for adding things to USD, and he often has said, okay, that's a great idea, but I want you to open source enough code so that USD View could handle that extension properly.
Yeah, I do. I mean, we haven't tried it. We have been running it in a Hydra compatible renderer that we use internally and to successfully render Nerf assets. We haven't tried with Storm yet, so I don't know if what it will take, but I'm guessing may not be. I know maybe Ray or Jay can correct me on this, but I'm assuming may not be a super complicated task to make it running in Storm.
Scott?
Yes, Raymond, I've got a question about the, I think you mentioned in the slides, the PLY format. And I'm wondering if I've got that right, that's the PLY 3D format. And is there a reason that you mentioned that specifically in your presentation? Is the PLY format more amenable to accepting the kind of data that you're generating?
So PLY format is designed for point cloud, but the more important reason we are using it is because on the two major, I would assume it's major capturing platforms, which is Luma.ai and Polycam. they all can share the GSPAT as PLY format. So I assume that's something that people has adopted as one of the major format for GSPAT. So that's why we're also using it here.
Right, thanks.
Yeah, for research also, a lot of researchers, they like those super simple file formats that they don't need any dependencies and they quickly can write it. So then that's why OBJs and PLYs, those files will never go away because they're useful for in that. So that's why PLY took off. It was just convenient, I'm guessing.
And have you threaded through to glTF USD?
Yeah, so we do consider the interconversion between this three format. Yeah.
So I'll double check if when, because I don't know yet where we are. So when we're going to release the glTF, PLY, and UST plugin out there, I need to check if automatically some of these data will be converted as well, even if it's still not a fully defined schema, because again, they may be converted, but they may not be doing anything for others. But I'll double check if the code is already there, and maybe okay to leave it in there, but just the caveat that the schema being produced may not be a final one.
Yeah, because sometimes that can get a bit tricky, can't it?
Yeah, it'll be interesting to see what Eros comes with next time. But you know, I expect the GSpot format in particular to evolve as you know people start to take something that's actually been around for over a decade and add small MLPs instead of spherical harmonics and do performance optimizations. Yeah, right now it's a big pile of 32-bit float points, so there's lots to iterate on.
And then what about for NERF? Because then I think Guido maybe alluded to the question, because it's always this trick shot for like you don't want to standardize too soon, but you don't want to standardize too late if the market gets fragmented. So for folks knowledgeable in NERF, any sense for if that is stabilizing and there's broad interest, or?
Yeah, from what I can tell, NERF seems to be more mature, and there are quite a widespread open source project that have the definition of the data. That so when I asked the researchers, what they feel like that may be more converged a little bit more versus GSplats. But again, I don't know, Jay or Ray, if you want to, you know, if that's the latest, still the latest, or if anything changed in the last few weeks.
I mean, I think within a certain scope that is very much true. We're starting to see extensions like Smurf popped up last week with their opening of their implementation that really are about like extending NERF to have like scenes built from multiple volumes and like considering the LODs before you reach that volume, what does it look like? And we're starting to see yeah, people taking NERF ideas and applying them to GSplats. But I think for kind of the NGP use case of I have an asset, it is a NERF, things are starting to congeal.
So one thing that's I guess important to think about is when you capture NERFs generally from the real world, then they have the lighting sort of baked into them. But if you were going to use NERFs for LOD purposes, then you could create you know, unlighted NERFs. Do you support both of those? I went by a little bit quickly, so it's hard to see.
Yeah, no, that's a really great question, and that is something that we would like to maybe extend in future versions is specifically like relightable NERFs.
Yeah.
Even you know like without capture, like you can construct these things by sampling a bunch through synthetic assets and then.
Yeah, exactly. For I think that's a very good path for LOD, and I'd be ashamed to start using something that doesn't support that in a nice way, because as soon as you do that, then of course you can have a NERF asset that plays nice with all your other parts of the scene description.
Yeah, and it becomes like a true distribution format, right? Like you can take a 3D asset, which is notoriously hard to publish, and have photorealistic quality with a kind of a standardized asset format. So yeah, certainly. But I don't know. I guess the question is like that balance between too early and too late. Does it make sense to standardize on an NGP based format for a base and make sure that there's extensions available for relighting, considering that there's already value with the baked lighting?
Yeah, but I think that's really, to me, that's kind of baseline, right? If we're gonna do nerfs, we should do them in a way that supports nerfs that come from synthetic sources where delighting isn't a challenge. And so we should at least have, I think, the first the MVP for that, whatever that might be, because it would be a shame to have these nerfs everywhere and then just not have it even possible for them to correctly interoperate with all the other geometry that we have in USD.
Yeah, no, it makes sense. Maybe that's the moment where we achieve that. Maybe that's a requirement before you can standardize an asset that needs to be properly rendered with the other ones.
Yeah,
that's a good rationale,
MVP, right? And then okay, you have some that can't do that, but at least you've described it in such a way that it can do that. And I think the LOD case is a really valuable, important one. As soon as that's there and it's widely adopted, then you have this problem where you have an asset. It's made up of a zillion pieces. You can't just use Simply Gone or something like that to reduce the number of elements in a particular mesh. It's more complicated. But a delighted nerf actually gives you the right kind of sampling that you want when you're not super close to it. So I think that's very valuable and an opportunity we don't want to miss out on.
Yeah, we do have recently got a relightable nerf paper from our researchers. So yeah, that's a potential direction we're looking into.
Yeah, I mean, to get a relightable nerf from the real world is a challenge, and it'll take a little while before that's really solid. But if you start from a synthetic asset for a level of detail purpose, then it's very straightforward.
Other questions? So maybe related to this, real world captures. So the work we do at Cesium is massive scale. It could be a city, it could be a globe. I saw the 32-bit floats there for the nerf. So I'm curious, if you think nerfs would scale right to a whole world, or if you think there's going to be different representations for that.
Yeah, we do compare them, try to compare them on the large scene captures from our researchers. But recently they're both advancements in GSplat and NERF for our understanding. Because for example, on NERF, we recently have the MERF paper, MERF paper, that where you can delay loading of some part which is not in the view, and then when the view is there, you start to load it or streaming it online something. Yeah, we are closely looking into that. We're also interested in how the other people, or what's the other people's practice on handling larger things.
And the same kind of wondering about streaming applies in GSplat land. Seen some nice results at deferred loading for very, very large. These things can get quite huge. So even just loading locally, the streaming can be a benefit.
Cool. Cool. And then in chat here, Nick is mentioning that Ras has looked at partitioning as well, and he'll be here in 2 weeks to talk Gaussian splat. So Jay and Ray, you're welcome. You're welcome back then, and anytime, of course. Other questions? All right, so I had another question. I usually don't have as many questions, but this is a very good topic. And this one maybe is beyond standardization, but I mean, how far do folks think NERF could go in terms of, is this something that could make it all the way into a GPU representation? And, does it replace the triangle in 30 years?
That's a tough one, but if you think about it, volumes at some point we will represent everything with volumes. It's just a matter that we don't, because it's too much to go down to super small volumes. So who knows, maybe one day, in fact, you represent things like, because conceptually those are volume-based models, and so I wouldn't be surprised that at some point the data that you can store and manage in the devices and GPUs and all of that is so large that it's actually convenient to just rely on volume-based representations. But again, I don't know when, how long.
Yeah, so mesh is more like a you can treat it as some kind of compacted format from a volume representation. Yeah, I would say if the capturing technique is more mature, or photogrammetry is more mature for neural sets, I would see that day coming in the recent future. Because, for example, if you're working on mesh, you need to consider about UVs, about the textures, and everything. It's just like in old time, a painting versus camera photo. And now we have the 3D version of the camera, which is NERF or GSPLAT, and it's much easier, much more democratized than let people to learn painting. So I think that day is incoming in the near future.
But replace the triangle is a very strong word.
It was a question. I didn't.
Yeah, it's
That'd be
great.
a big lift.
I like you could make the analogy to like bitmaps and vector graphics, right? Like the vector graphics are still around, but the bitmaps are way more accessible. So yeah, I think we'll probably end up there.
I mean, if you think about it, in a ray tracing world where you have a BVH and you have triangles inside, it is kind of a volume representation, right? The BVH is. So you hit the BVH and now you want to know what happens next. Okay, well, it could be a bunch of triangles inside. It could be something inside that you calculate by means of some kind of neural net, which is sort of what these NGPs are like. So I don't think they have their relative strengths and weaknesses. I don't think one's gonna go away, but yeah, it does look like everything starts to feel volume like instead of triangles at the as the primary thing. It's, oh, I have something in this volume and a way to figure out how array interacts with it.
Yeah, and I would say the same thing for optimization and ML training. Like the format fits a lot better than meshes and scene graphs.
Cool. Other topics? Other questions? Cool. So Guido, sounds like Adobe is going to do the open source project in a few weeks, and some of this you said may or may not be in there, even as just a an unofficial extension.
Sorry, what do you mean an unofficial extension?
Just like not like an official glTF or USD thing, just
Yeah. Yeah, I mean, that's why the plugin will, yeah, well, I'll circle back to see where we are with those extensions, and maybe if we add in the plugin, maybe we can put a little description there about those. And then the discussion is the shader is the big thing that we need to think about it. Do we want to put it somewhere so it can be accessible by everybody?
cool. Ray and Jay, were there other input or questions you were thinking you were going to get, or input you were looking for from the group?
It's been a good conversation. I guess we're trying to, put a finger in the wind and see, where everyone else is with this. We just want to open the conversation, and it's a little bit of like, I show you yours, you show me mine. One of those moments. Are folks feeling like neural graphics is something that they're investing in as a format? And is it something that they feel is stable for specific use cases? I think keeping the use cases in mind is important. And if so, like, what else is on the table that needs to be considered? Because we don't want to propose something that carves out really important use cases or really important customers. So really like looking to open the conversation and hear all the sides.
So I know many of us came on the call to learn, but yeah, I'm curious. I'm sure there's other folks on the call that have been using them and maybe could share some insights. What do people think? Okay, well, maybe we can follow up if anyone comes up. So we're doing great on time. So I'll just do one last call for the official part of the meeting if there are other questions. See, James, appreciate the kind words there on the chat for the work Raymond and Jay you guys are doing. Cool. Well, why don't Raymond and Jay, so we have our official meeting that's recorded, and then we do water cooler afterwards for folks who want to stay. Sometimes that goes past the hour. So why don't we last call, any official business for the meeting? Okay, well then one more thank you for Raymond and Jay.